Hi, I'm Jason, K4APR, and in this presentation I'm going to be talking about the ESP32 APRS tracker, the ESP32 APRS mini terminal, and the ESP32 Lore module. Just a quick introduction. Again, I'm Jason Rausch, K4APR. I live in Chesapeake, Virginia. I've been licensed about 30 years, and my particular interests in the hobby are packet, APRS, DMR, and P25 digital voice audio. I was recently asked to join the APRS Foundation Board of Directors, so I'm very proud of that, and that makes APRS very near and dear to my heart. And then last, I own and operate RPC Electronics LLC. My partner and friend in these projects is Remy Bilodeau, and he's located in Prusik, Quebec, in Canada. He's been licensed about 33 years, and he's also in APRS, obviously, and he also does a lot with LoRa and solar-powered weather stations. And I call him the embedded programming master. There's no way I could do any of these things without his amazing coding ability, and he really makes all of this work. So the first thing I want to talk about is the ESP32 APRS tracker. This is an update. I originally presented a paper on this back last year at the 2022 Charlotte DCC. So the primary thing that has changed is we solved the transmit audio problem that I reported in my original paper. It was due to a clock multiplier error carried over from the old YAG tracker base code. That's a APRS device that Remy and I had designed and worked on together many years ago. And a lot of that base code was brought over, and he reused a lot of it, but we did find an error in there, and luckily that solved our issue. Another change we made was going from a USB micro connector to a USB-C connector. It seems that everything's really going in that direction, and it's a much more robust connector compared to the USB micro. We did have some transmit audio low-pass filter improvement by tweaking some of the cap values. Another thing we did was we added a bunch more LEDs. Well, not a bunch. We added a few more, but we now have an LED for power, transmit, DCD, receive when you receive a good packet, Bluetooth, Wi-Fi, and GPS status. So those LEDs at a glance will tell you what the tracker's doing and what state everything's in. We also added a button to act as a Wi-Fi access point on boot button. And what that basically is when you hold that button on power up, the tracker will create an access point over Wi-Fi that you'll be able to connect to and go to a web browser and do all your configuration, and then when you power cycle the tracker, it will go back into normal tracker mode. We also improved the multi-decoder routines. Right now, it will run the packet through multiple decoders, and it will try to find a way to decode every single packet. And with our tests, we've had some very, very good output from those routines as far as being able to decode the packets coming in. We also had the tracker time slotting feature, and this basically is using the GPS to time slot multiple trackers, so you can tell tracker 1 to start at the 0 of the 60 seconds of the minute. You can tell tracker 2 to do it at 5 seconds, 3 is at 10 seconds, and so forth. And this ensures that if you have multiple trackers on the channel, they will all transmit in their little time slot and never transmit over top of each other. So that's a new feature we added in. We have full Bluetooth support now for both the serial port protocol as well as iOS Bluetooth low energy. And we've fully tested that with Android and iOS devices, and it's working very well. Lastly, we've added some additional sensors. We can now measure voltage, current, temperature, humidity, and pressure all on the board. And the tags that you'll see there is %V, %C, and so forth. Those can all be inserted into the comment string on the packet, and the values for those particular tags, for example, %V is voltage, it will insert that voltage information into the comment. So this is a picture of the current hardware. You can see the LEDs are all lined up here on one edge, and there's a boot button up towards the top here, or I'm sorry, that's the AP on boot button we've added, and the USB-C connector. Other than that, everything else has pretty much stayed the same as the previous hardware. This is just a little breakdown of the hardware that kind of points out some key things, key features. For example, the humidity and pressure sensor, the voltage and current sensor, and of course that AP on boot button that I mentioned. Okay, let's talk about the ESP32 APRS mini terminal. So this is a full-featured APRS terminal with an LCD. It has a 320 by 240 TFT LCD with a resistive touch on it. It has a completely rewritten graphics engine from the original monochrome YAG tracker that we originally designed and sold years ago. The screens are all scaled up to fit that new resolution. They have full color icons. It has a map plot screen that has some color. We may even be adding in some icons if you're zoomed in really close where the icons would make sense to actually have them visible. It includes the same internal GPS and telemetry sensors that are on the regular tracker as well. And since this is compact and has the TNC and everything built in, it's a perfect addition to just a VHF radio to make a mobile APRS station, much like the Yaesu FTM 400 that just recently was discontinued. This is a good alternative if you don't want to go out and find one of those at a way marked up price. So here's the hardware from the back side. You can see that it has the same ESP32 processor. It has a mini DIN connector for the radio interface. We did go to the USB-C on this as well, and there is an SMA connector there for the GPS. And then we also included the CR2032 backup battery for the GPS so that we get very quick lock from a cold start. This is just an example of one of the screens. We call this the station detail screen. This is basically a live, whenever a packet comes in live, this is going to be what you'll be presented with. You'll see the call sign and the position data, or I'm sorry, the speed, heading, that sort of thing, the icon. And this changes as the packets come in. Now, those left and right buttons, you can actually scroll back and forward the last 10 stations, so you can look at some of the history that's come in. This is the station list screen, and basically just lists out all the stations that you've heard. There is a pop-up menu that will allow you to sort this by distance, time, and so forth. And those are all accessed with these buttons on the bottom of the screen. This is the map plot screen. It does look a little cluttered right now. As you zoom in on the stations, it's less cluttered. There is a declutter function that will allow you to turn off the call signs and just go to little circles. And those little circles are nice if you have a lot of stations and you're just trying to see what the station density is on the map. Then you can zoom in and then switch to the call sign view if you want to see the actual call sign of a station. Okay, last I'd like to talk about the ESP32 Lore that we've been working on. This is basically an all-in-one Lore device that we are kind of loosely coining the Lore Swiss Army knife. And by that I mean it can be a tracker, it can be a digipeater, it can be an iGate, it can be a Lore modem, or it's also a Lore modem. It's at its core, it acts as a Lore device, but it can be those other functions as well. It has a built-in 1-watt UHF Lore transceiver. Has onboard GPS, onboard sensors, the same as the tracker with the voltage, current, temperature, humidity, and pressure. It also supports the serial port protocol as well as Bluetooth Low Energy. It does KISS over Bluetooth to any device running APRS software, so I can connect to this with, for example, my phone running APRS Droid, and it will talk KISS between it and my phone, so there's no change of the protocol, and then any packets coming in on Lore will be sent back to my phone over KISS, formatted in that same way so that the software that I'm running, like APRS Droid, can just take the packets in as though it's a normal APRS packet coming in off of, for example, an AX25 channel. We also switched over to the USB-C on this. We had originally had a USB micro, and we switched over. There's SMA ports for the UHF radio as well as the GPS, and then there's an SMA reverse polarity port for the Wi-Fi and Bluetooth. This is a picture of our current hardware. You can see that the board is all-in-one, with the exception of these two jumpers that connect to the ESP32 for the Bluetooth and Wi-Fi, and then this other jumper connects to the Lore module itself for the UHF side of the Lore module. Here's another one of those breakdown diagrams. You can see a little bit better the various ports. You can see the E-byte module that we're using. It's the E32 400M30S. That's a transceiver. It's transmit and receive Lore transceiver. We are using the same GPS, the M10578. And the only real difference here is the ESP32 that we're using on this particular one does not have the embedded antenna for Wi-Fi and Bluetooth. Instead, it uses a MMCX connector to connect to an external antenna, which, as you can see through the gray jumper that's going to this bulkhead SMA, this is the reverse polarity SMA connector. And I thank you for watching.